Hello, my name is Shehryar Sardar, and this is my Physics 2212 Lab 2 Charge Tape Revisited. Today we're going to go over Introduction, Models, Experiment Code, Discussion, and Conclusion. The purpose of this lab is to observe interacting charged tapes to determine excess charge in the tapes, as well as to simulate the two charged tapes to find at what charge does one of the tapes balance out to gravity. We represent these tapes as lines of charged particles. The two fundamental physics principles we're going to use in this lab are Coulomb's law, which tells us that the force between two charged particles is directly proportional to the charge and inversely to the square distance. We will use this to balance out the gravitational force to determine the amount of charge exerted. Secondly, we have electric fields, where every charged particle exhibits an electric field in all the space around them, changing whether they are positive, negative, or dipole. This will be used to determine the amount of charge exerted on the opposing charged tapes. The models we use in this lab are the electric force, electric field, and gravitational force equation. Some assumptions we can make for this lab are to ignore air resistance on the tapes, as well as to assume charges are evenly distributed along the length of both tapes. Here is a results preview of this lab, where we can see with charge of 1.25 E negative 8 coulombs, we were able to balance out the electric force in white and gravitational force in yellow. For this experiment, we had tape B, the upper tape, which is part of the system, the Earth, which is part of the surroundings, and tape A, the lower tape, which is part of the surroundings. Step 1, we charge the two tapes so they are of the same charge. Second, we tape the upper tape between two ledges by its ends to not dissipate any charge. And lastly, we held the lower tape slightly below at some distance to the upper to make it repel upwards. For this experiment, the data we collected was that the measured separation distance at floating time was 0.013 meters, the mass of the tape was 0.0001 kilograms, and the length of the tape was 0.1 meters. To start off our code, I defined my constants, mainly K, gravity, and mass. Then I followed with the variable for change, which I can trial and error to find the charge of the tapes. Then I used the line charge function to create two lines of charges, representing the top red and bottom blue tapes. Lastly, I defined the E field function to calculate the electric field of the line of charges on the top tape specifically. To calculate the electric field on the top tape, we looped over each of the top tape charges. Then for each of those, we looped over the bottom tape charges and found the electric field from each bottom tape. Adding those up for all the top charges, we found the net electric field and electric force. For gravity, we simply used the gravitational force equation in a vector in opposite direction to the electric force. For our results on the left, given a charge of 1.252 E negative 8 coulombs and 25 charges, we found the magnitudes of the electric force and gravitational force to be nearly equivalent. And on the right, given the same charge and 3 times as many of charges, the electric force and gravitational forces are still relatively similar in magnitude. One similarity between the models is that the gravitational force stays the same no matter the model, and one difference is that calculating for a point charge compared to the line of charges would give separate charges for the tapes, as we will see later. And a possible source of error could be the measurements not being precise during the experiment and poor handling of the tape leading to charge loss. Comparing the charges between a point charge and a line of charges, we can see that the charge of the line of charges is much bigger than the point charge as is the electric force. And why do these estimates differ? It's mainly since the line of charges allows for fields of all the particles along the entire length of the tape to affect the particles on the length of the other tape, whereas the point charge only acts as a single point, and a line is more accurate to a tape. In conclusion, we were able to upgrade our model and determine a more suitable charge for two charge tapes to balance out with gravity. Thank you and have a good night.